Far above our planet, orbiting at an altitude of about 260 miles, the International Space Station continues to serve as humanity's most advanced outpost in space. In a recent glimpse, cameras captured the station soaring over the golden sands of the Saharan Desert in Libya, with its massive 57.7-foot-long robotic arm, Canadarm2, stretched out into space. Attached to this robotic arm is Dextra, a highly sophisticated robotic hand designed for delicate and precise tasks. Together, these robotic systems act almost like the extra hands of astronauts, allowing them to carry out complicated operations, repairs, and science experiments without stepping outside the safety of the station. This image is not just a snapshot of technology floating above Earth, but a symbol of how far human ingenuity has come, and how it continues to push forward. The end of this week on the station was especially significant because the crew of Expedition 73 turned much of their focus toward biomedical research, an area of study that may hold the key to protecting human life during future missions to Mars and beyond. One of the most fascinating experiments involved the production of human tissues in space. Thanks to a SpaceX Dragon cargo craft that arrived on August 25, researchers now have access to bioprinted liver tissues aboard the orbiting laboratory. These tissues are part of an investigation into how microgravity impacts the way blood vessels form inside engineered human tissues. On Earth, gravity influences how cells grow, interact, and organize themselves. But in microgravity, these rules change, sometimes revealing hidden mechanisms that are impossible to see under normal conditions. Astronauts Zena Cardman of NASA and Kimiya Yui of JAXA, the Japanese space agency, carefully handled the bioprinted tissue samples and placed them into a device capable of simulating artificial gravity. Over the coming weeks, researchers will monitor how these tissues develop and progress, hoping to uncover new medical insights. The long-term benefits of such work could be transformative. Not only might it provide solutions to protect astronauts during prolonged space journeys, but it could also revolutionize patient therapies back on Earth, especially in the field of regenerative medicine. If we can master the process of growing stable, functional tissues in space, the dream of creating replacement organs for patients may one day become a reality. But the focus of the crew did not stop at tissue growth. They also continued to study a very common but potentially dangerous condition astronauts face in microgravity: fluid shifts. In space, without gravity pulling blood and other bodily fluids downward, these fluids tend to pool in the upper body. This leads to what astronauts describe as the puffy face effect, where their faces appear swollen and red. While it may seem harmless at first glance, the condition can create increased pressure in the head and around the eyes, sometimes leading to changes in vision and even long-term damage to eyesight. To counteract this, NASA astronauts Mike Fink and Johnny Kim performed a detailed test inside the Columbus laboratory module using a specialized thigh cuff device. This device works almost like a belt placed around the upper legs, gently restricting blood flow so that less fluid shifts upward toward the head. During the experiment, Fink wore the thigh cuff while Kim measured his blood pressure, scanned his veins using the station's ultrasound 2 device, and monitored his heart activity through chest electrodes. Every detail of their body's reaction was recorded, from changes in cardiac rhythm to the flow of blood through their vessels. By studying these effects, researchers hope to find reliable countermeasures to protect astronauts' eyes, brains, and cardiovascular systems during long stays in microgravity. Such findings could make future missions to the Moon and Mars much safer. Meanwhile, Roscosmos cosmonaut Oleg Platonov was involved in another essential biomedical study. For a continuous 24-hour period, he wore sensors that tracked his blood pressure and heart rate as he went about his daily activities, exercised, and eventually slept. Doctors on Earth carefully monitored the data, which offers valuable insight into how the human body adapts and performs under the unique conditions of space. Studies like this not only safeguard astronauts but also improve our understanding of human health While scientific research was front and center, the Expedition 73 crew also had to prepare for a busy period of space traffic. Station commanders Sergei Ryzhikov and cosmonaut Alexei Zubritsky began training with the Toru, or tele-robotically operated rendezvous unit, inside the Zvezda service module. This simulator allows cosmonauts to practice manually controlling a spacecraft's approach to the station. Although spacecraft normally dock automatically, Toru provides a crucial backup. In the unlikely event that an incoming Russian Progress cargo craft cannot dock on its own, the crew can step in and guide it safely using remote controls. This type of redundancy is vital for station operations, ensuring that supplies always make it to the orbiting crew. This training is especially timely, as 2 major cargo missions are scheduled to arrive this month. The first will be Progress 93, a Russian spacecraft packed with about 3 tons of supplies ranging from food and fuel to equipment and scientific instruments. It is set to launch on September 11 at 11:54 a.m. Eastern Time, with docking planned 2 days later. Barely a day after Progress docks, another resupply mission will set out from Earth, this time a Northrop Grumman Cygnus XL spacecraft, launched atop a SpaceX Falcon 9 rocket from Cape Canaveral Space Force Station in Florida. Scheduled for September 14 at 6:11 p.m., this mission will carry more than 11,000 pounds of science experiments, supplies, and hardware for the crew. Once in orbit, Cygnus XL will spend about 2.5 days circling the planet before catching up with the International Space Station. Unlike Progress, which docks itself, Cygnus will be carefully captured by Canadarm2, the same robotic arm that was recently photographed extending across the void of space. The crew will then guide the spacecraft to an Earth-facing port on the Unity module, where it will remain attached while its cargo is unloaded. These resupply missions are lifelines for the station, ensuring that astronauts have everything they need to continue pushing the boundaries of science and exploration. All of these activities, bioprinting human tissues, studying blood shifts, training for spacecraft docking, and preparing for vital supply deliveries, demonstrate the delicate balance of life aboard the space station. Every experiment, every training session, and every cargo mission adds to a greater purpose: understanding how humans can survive and thrive beyond Earth. The knowledge gained does not just stay in orbit. It finds its way back to our hospitals, research labs, and technologies on Earth. From regenerative medicine to improved cardiovascular health, the ripple effects of space research touch us all. The International Space Station is more than just a scientific laboratory in orbit. It is a symbol of global collaboration, where astronauts from NASA, Roscosmos, JAXA, and other space agencies work side by side to advance knowledge. Each day on the station brings new discoveries, new challenges, and new possibilities. As Expedition 73 continues its mission, the experiments and preparations carried out this week remind us that the work being done up there is paving the way for the next great chapter in human exploration: the return to the Moon, the journey to Mars, and perhaps one day, the